only a few. So we started with only a small founder population, and we brought them in captivity. Started in the Rotterdam Zoo, but later on, Gaia Zoo in Kerkrade started the breeding of the hamsters. Now we have also the breeding in Meetlen, North Rhine-Westphalia, which is a huge support. But if we hadn't trapped the last individuals, we would have lost the hamster in this region. Okay, when you have a captive breeding program, it's also an emergency solution. It's for the short time. You want your population, of course, in the wild. You want your wild population to flourish and have it in a sustainable way, which is far away if you start with only 25 individuals. But well, they are hamsters. They in captivity they breed quite well. They do not breed that well in outside, but that's another story. That's more for Stephanie, I hope, to tell more about it. But when you release them in an alfalfa field or cereal fields, and if you have a very nice alfalfa or cereal field, you won't see any hamsters. You release the hamsters and they're gone. They're somewhere inside the crop, but you cannot follow them. There's not like eagles with little large, and you can follow them with your binoculars, etc. Small individuals somewhere in your agriculture field or in your agricultural landscape. So we follow them with implanted transmitters, and then if you can start monitoring, following them, monitoring is knowing. Then you know what is happening, and the hamster is a prey species. They are eaten. They're eaten by musclets. They're eaten by birds of prey. They're eaten by foxes. You can even see the nest of the. I'm not sure, but it's probably you see the white spot on the nest. That's the transmitter. That was the hamster. They are eaten. It's a prey species, and you have to have much hamsters. Not 30, not 300. No, you need 1,500, 3,000. You need thousands of hamsters. And by monitoring them, you can see what is happening with your hamsters. There are differences already mentioned by Sarah this morning. You have the males and the females. The upper part, the upper map, the blue ones are the males. They are running around looking for mates, females to mate. And below you see the females, which are just very smaller territory. They are on one field. They stay there. They have their litter on site, and they do not much. They just sit to wait till some stupid male is coming around to fertilizer. So if you're a male hamster, you have a problem if you have to be the first with the female, or otherwise she's already fertilized. So you have to run around, and then you meet all kinds of friends or not so friendly other animals which kill you, etc. Okay, so we have the difference in males or females, and we have, of course, also the difference in if you're born in captivity or if you're born in the wild. If you're born in captivity, you know your the people who care for you, your caretakers, who like them. They bring you food every day. You can confirm that. And you have the wild ones, which are just very scary for anything. Which just if they want to eat, they do you just outside the burrow entrance and then quickly back into safety. So you have the captive bred, which are naive, and you have the more wild ones, which are more sensitive for all kinds of danger. There are the main differences between the main factors which influence the survival of hamsters, if you're captive born or wild, if you're a male or a female. If we look at, we have the last 20 years, we have followed hundreds of hamsters. I should have had an N, the number also inside the graph. It's also in the thesis. If you look at which animals, predators eat hamsters, or why hamsters die, you see a fox as a most important predator. You see musclets, eeltis, stoats, sometimes a weasel or a stone martyr, and you see birds of prey. That are the main predators. 3/4 of your hamsters is eaten by all kinds of predators. Only a small part of your hamsters is directly killed by farming activities. Directly, I said directly because there are also secondary effects which will come on later in the presentation. So 3/4 of your hamsters is killed by predators. And of course, there's a percentage which is unknown, which is lost or whatever. So when we knew that predators were the main mortality cause of mortality of hamsters in the Netherlands, we the hunters asked for, well, we can shoot foxes very well. Maybe shoot foxes. Okay, we said, well, if you want to shoot foxes, go ahead. And we had also a control. We did an experiment, some areas with spotlight hunting and some areas without spotlight hunting. And the effect was that spotlight hunting had no effect whatsoever on the survival of hamsters. We have at several times that we had to ask hunters, well, you were shooting foxes, but we find our transmitters back on that fox den over there. Ooh, is there a fox den over there also? They miss it. Hunters like to hunt, but they're not very effective in reducing the predation pressure of at least foxes. It's not allowed to hunt birds of prey in the Netherlands. Fortunately, it is allowed to hunt foxes, but hunting fox had no effect on an increased survival of hamsters as far as we can see in our data. Which had an effect was electric fencing. Put an electric fence around your field, which allows small mustelids, small predators and birds of prey to enter the plot. But if there is a high crop, it's still difficult to find a hamster, but it excludes foxes. And that works. Probably it also works because there are less other people or other predators walking through your field, but we see a positive, significant effect on the survival of hamsters within an electric fence. If you want to do something for your hamsters with some anti-predation measures, use an electric fence. Yes, you have to be there every week or every 2 weeks to cut the grass, to have enough electricity on the fence, but it works. But also it can only be applied on small scale. It's of course not a solution for the long term, but it is possible to at least protect your small population. I would rather advise also in Flanders and Wiedooije, use more electric fences in your area. It helps saving hamsters. Yeah. Okay. Now we come to the management part. So hamsters need sufficient cover of typical agricultural crops. They have a strong. They very much like crops like cereals and alfalfa. They don't like potatoes. They don't like sugar beets. They don't like maize. With some more talks this day. Also from France, with a lot of maize in the area, but they like cereals and alfalfa because it gives it's a crop which gives cover, it gives food, and they can walk through the plants. It's a very attractive crop as long as it is not harvested yet. If it is harvested, it is again your cover is gone, and you're a sitting duck in the middle of the field, and you're probably as a hamster killed within a few days or a week or whatever. They need a cover, and harvesting means losing your cover, which is problematic. We've modeled the hamster ecology, the hamster cycle, and we found out that a hamster, this moment with this survival and this number of and a mean number of 5 pups per litter, which is in practice even lower. A hamster needs at least 2 litters to have a sustainable population. And the lines you see is the moment that the harvest, the cereal harvest, starts. And if you look at the dark gray dot, that's the first litter. It's born in the middle of June. And it's harvested. The harvest started well beginning of July, maybe sometimes even second half of July. And it's sometimes possible to have a litter and to raise all the juveniles before the harvest is starting. It's only 1 litter, and the second litter, the light gray circle, is already too late. It's no way that if in a normal, regular agriculture management, it's possible to have a second litter of hamsters in your crops at this moment. So by delaying the harvest, it's possible to give the hamsters a chance. This is the same graph, only with more colors. The hamsters hibernate, of course. They have the first litter in June. July is also a very important month for the hamsters. Maybe a part of the females will have a second litter, a very small part of a third litter. But you see the red line is the moment of harvest. Well, at the moment it's impossible for hamster to produce enough juveniles to have a sustainable population in the long term. What's even more problematic is the loss of suitable crops in the last decades. At the moment, there's 25% more or less of all arable fields is at the moment cereals or alfalfa, and most of the cereals are regular managed, and only a small part is hamster-friendly managed. And we lost some very important areas, the service of other suitable crops. We now have much more sugar beets, we have much more maize, we have much more potatoes in the Netherlands. And they have retreated to the last fields with cereals, and even those last cereal fields are harvested too early with regular farming activities. That's not the problem. It's not the fault of the farmers. That's how our farming practices has developed the last decades. And what we're now trying is to implement new agriculture management with restrictions, later harvesting, more cereals on the arable fields. We try other crops. We have done experiments with. We tried other crops to grow on the fields. And we also found out that it's no problem to rotate with your crops on a farm. Farm is not really problematic. We are trying to get as close as possible to regular normal farming with our hamster-friendly management. Still, that's a huge challenge. This is hamster management in practice. This is a hamster. If you wake up in spring as a hamster, you can choose for the photos on the left, which a cereal field with no fertilizer and with where herbicides are banned. Then you have a nature-friendly field, which is very open, or you can choose for the regular farmer with dung and herbicides, etc. So you, as a hamster, you doesn't choose the hamster-friendly field, but you choose, of course, for the regular management, where you litter will be harvested once it is 2 or 3 weeks old. So it's we have created an ecological trap. Well, once we found out that we had a ecological trap, we tried other ways of improving the management, and it's the cereal stripper. I will also think cereal killer, but the cereal stripper. By only harvesting the cereals, how you call it, corn. When you only harvest the grains, the corals, you have some benefit from your crop, but the stems are still standing, so you still have your cover. And as you can see on the photo on the right, there's also some grain on the ground for the bird or for your winter storage. Well, we found that so we adjusted the management, and then it's the time to implement it on. This is how it looked like. The seeds which just fall on the ground will start growing again in autumn. If you don't plow it, then you have a very nice field with cover and food for your hamster to hibernate, and also for all other kind of arable species. So even if you have an area with a large of a large amount of habitat. This is the one of the area in the green are all fields with some kind of measure, some kind of hamster-friendly measure. It's still not enough to have a population in the long term. Sometimes we have a few good years, then we see increasing numbers of hamsters, and then we have a very bad year because of rain or because of drought or whatever, or because of heavy rains in spring and months of drought in summer, and then again heavy rains in autumn. So maybe there's also some climate change effect killing our hamsters at the moment. At least it's even in this area. It's not. We have not achieved a sustainable population with hundreds of hamsters. It's still quite difficult to have enough hamster-friendly management. The last problem, the regulations, the common agriculture policy. That's a jungle, and it's almost impossible to get through, to have really measures which works. And in this case, this example, you see the gray area, and you see a small gap out of at the bottom, and that's a problem. This map was made by the government, and you see that it's now overlapping with the buffer of the green area. That's not possible, at least according to our government. It's not possible. The government made this map. They made a mistake. The gray area is hamster-friendly, and it may not overlap with the buffer zone of the green area, which was developed, which was put in GIS by the government. So the government say, we made a mistake. So you have hamster-friendly management for 6 years, which is about, in this area, about several 10,000 euros. So we as a government made a mistake. You have hamster management. So you have to pay all your hamster management, all your finance. You have to pay us back because we made a mistake. If you do it once by a farmer, this kind of example, he is not willing to do any hamster-friendly measures whatsoever anymore. Because the government makes a mistake, the farmer says, etc., and you lose again one of your farmers, which was willing to cooperate. Well, this is the graph which was updated recently, thanks to Gerard. The red line is the number of hamster burrows. In the first years of the hamster meetings, I could say till 2007, we are doing great. Our hamsters, with an all-time high in 2007, with more than 1,100 hamsters. And after 2007, our decline started, and we're now declining. However, the number of hamster management is the green line is increasing, but still we haven't made it. We haven't found a solution how to increase our hamster population again. Although we have more management, we still are releasing hamsters, but still the population is on a very low level and doing not so well. Well, to end with, we only can save the hamster with some fundamental changes within the common agriculture policy. There must be much more interest, and we should put much more energy in a hamster-friendly common agriculture policy. That's a really, really tough job. And I even haven't mentioned the ongoing decline of the litter size, which is also very worrying. Remember the article of Stephanie from a few years ago with a declining trend of the litter size. We have till 2030, I think, then the mean litter size will be 0. I don't have to tell you what it means. Well, never mind. Don't give up. Message, take my home message. Don't give up. Although we probably, I think, to be honest, we will lose the hamster in the next 10 years. I think it's worth trying to keep it as long as possible, and at least it's supporting all our kind of arable species, which are also important. We look at hamsters, but we also have to look at birds, small mammals, butterflies, and our farmers, for instance, also. Very important to keep our farmers. So thank you for your attention. If you have any questions, ask in the pause, or don't forget to take the thesis as you like. Thank you very much.
Thank you, Maurice. We have one question already from the online from the people online. There was a remark or question whether the fact that you didn't include plots of land that are lying fallow as a potential habitat for that, or is that by accident, or is it just linked to the fact that there are not a lot of plots that lie fallow?
There are no fallow lands in the Netherlands. All
Voilà,
land
there
is
you have
used
your-
by farmers all year. Arable land is quite expensive in the Netherlands, and farmers use everything in a very intensive way.
There is one. Michael, if you want, you can voice your remark.
Thank you. Regarding the hamster-friendly management, I have. Why do you think that no fertilizer, no herbicides is a hamster-friendly? I suppose it has nothing to do with hamster-friendly management. And in fact, you show that it's quite opposite. That it makes area less hamster preferable. I would say that the only thing with these sites is only the rodenticides that should be really avoided. I don't know if there is any practice in the Netherlands, but in Ukraine we have a huge problem with rodenticides when they use these very severe rodenticides, and we did encounter hamsters, both species of hamsters killed by rodenticides on the fields. And yes, indeed. What I want to say that fertilizers are okay for hamster-friendly management, in my opinion, but rodenticides are not. And if I would also want to add that, in my opinion, what could be done possibly is that there should be some sort of a market for these hamster-friendly food, let's say. Yeah, if the farmer loses part of its harvest, but if he can sell some it at higher price, then everybody would be happy. Hamsters, farmers, and the consumers who want to pay extra for, let's say, better food, or if they know that these products are environmental friendly. And again, I want to say that environmental friendly should not be mixed with this so-called bio food and eco food and with zero GMO and stuff like that, because this is gimmick. This has nothing to do with really environmental friendly farming. Thanks.
Okay, thank you, Mikhail. That was a very valuable input. I think in view of time constraints now, we have basically two options. Either we just, Marie-Cécile, give you the floor before the break, or if you agree, we go for a lunch break first and we start with your presentation after the lunch break. You can choose. After the lunch break, okay, if that suits you, then I would say now we have 1 hour. So for the lunch break, which will take place? We'll guide you to the. And so for the people following online, we restart at 5 to 2. Yes. De microfoon. Dat is bijzonder.
Ik vroeg me af wat dat ding was.
Ja, ik ben er ook niet vertrouwd mee.
Dus ik kreeg
Ja, die richting.
Ja, ik heb niet op slot, maar ik kan het vragen om. That's me.
We will not close, probably will not be able to close the room, so to lock it. So best to recommended to take your stuff with you, at least your valuables. If everybody can see it, please, then we can continue with the session. Okay. So when preparing the workshop, we also find it very crucial to invite people from France for two reasons. First of all, because there's a lot of, a lot of work being done in France on the protection of the hamster. Big action programs, which are quite impressive. So we are keen to know how, whether we can find good practices there. And also France is by now the only country in Europe which is actually has been condemned by the court 10 years ago. And it's also good to see how this has influenced the policy and whether it really helps or not. So we're looking forward to it. So Marie, yeah, the floor is yours.
Okay, thank you very much. So, hello everyone. So it's a really great pleasure to be here today. Maybe first I will introduce myself. So my name is Marie-Cécile Virion. So I work for the French Regional Office of the Ministry of the Environment. My missions are about protected species and more specifically about the hamster, about the National Action Plan. This is this plan I will present you today. Maybe just before a few words about the title of this presentation. The title was The Wild Hamster in Alsace Back from Extinction. I didn't choose it, but I think it's really a great title because it's a question, so we are not really sure yet. That shows how it's difficult to manage this species. We have always lots of things to know about the hamster, about its biology. And sorry to spoil you, but hamsters is not saved yet in France too. So we still have lots of work to do. And I'll start with the National Action Plan if I... Okay. So just to begin with a bit of history, because the hamster history in France is quite old. As you can see, the protection of the hamster is a history of more than 20 years now. Just focus maybe first on the different national action plans, so NAP, I put it on the timeline. The very first one began in 2000, okay? And at this time also began the first countings of the hamsters, and really early, we begin a reinforcement program because the populations were collapsing. And you can see also all the habitat improvement measure. At the beginning, it was just few contracts with few farmers. And then we create a area dedicated to this habitat improvement. And each 5 years, but I will speak about it later in the presentation, each 5 years, we try to improve the rules of the measures, the agricultural measures, to make it more and more benefits for the hamster. And in the red part, you can see the European litigation we have. So you already heard it earlier. So in 2006, it's a complaint lodged with the Court of Justice of the European Union by an NGOs, okay, which called Sauvegarde Faune Sauvage in France. And some years later, it's conviction of France by the CGEU for breach of the Habitat, Fauna and Flora Directive. Okay, so in response, we do more efforts on the habitat improvement, and we do regulatory areas, but I will speak about it later. And just to see the location, so In France, we have hamsters only in the Alsace region, okay, and in 3 areas, okay, which are called the North area, the Middle area, and the South area. And in total, it's more than 8,060 hectares with like a hard protection. Because these 3 areas are protected by a regulation. Okay, you can't do whatever you want in those areas. You can't build a project. You will have to respond to the ministries, the states, to explain why, and if you maybe if you can do your project on another land, because this land is really for hamster. So it's agricultural land, and the little yellow spots you can see are burrows on the 2021 year. So just some figures now at the top of the screen. So you can see in blue, it's the number of towns with hamster burrows. Okay, so in 2022, we have 24 towns with hamster burrows. And in red, it's the number of grid of 25 hectares with burrows. So in 2022, we have 126 grid with 1 or more burrows. So this is to show the range of the species, okay? And at the bottom of the screen, in green, you have the number of burrows. So in 2022, we have 960 burrows. And the line, the green line, it's an average on 3 years to see if we can have a trend or not. So about these figures, the counting is with the actual protocol of the French Biodiversity Office. And just to remember, this protocol is about counting the hamster burrows only in favorable fields, so in alfalfa and winter crops. It's each year from April to May. We were not able to count in 2002 because of the pandemic, so we don't have figures. We don't know what occurs at these years. But in 2022, we have really good results. Okay, more burrows and a wider range. But still, in some places, populations are still decreasing. So it depends on where we are on the map. Sometimes it's really a good year, sometimes not really a good year. And as you can see, 2021 was not really a good year. It was a huge decrease. So it was, we were waiting for 2022 really hard to see if it will be a good or a bad year. So it's a good year, but we have this phenomena of good and bad years, and we can't really say why for that moment. Improved quality of hamster habitat and reinforcements are still needed to reach a viable population, because we are still not a viable population yet. So that's why we have national action plans, and I will just explain what's a national action plan, because this is a French tool. A national action plan must be built in cooperation with all the actors involved, with all the stakeholders. That is not a regulatory tool, okay? You can't impose things in your plan. It's guidelines, but it's written in the French law that we have to write this kind of plan for endangered species. So we have to do it. And the aim is to set up a local strategy, so research or field measures or others, in order to save threatened species. And you have different topics and different actions. And the actions must have a priority, okay, to the one, okay, very important action to conserve the species, and 3 less important action. If we can't do it, the species will still keep going, okay? So about the French National Action Plan, so this is actually the fourth one, okay? We had 3 plans before. So it was written by all the partners involved, the Chamber of Agriculture, Association of Farmers, the National Center for Scientific Research, the French Biodiversity Office, breeding centers also, environmental NGO, and so on. So it's really a lot of partners. And the plan coordinator is the local office of Ministry of Ecology, so DREAL in French. And it's the first program that will be on 10 years and not only in 5 years. So there are 2 main goals to this new action plan. First, obviously, to save the hamster, okay, by reaching 1,500 hamster on 600 hectares. That's the first aim. And the second one, it's also to consider the biodiversity in the Alsace plain, because there is not only the hamster, but lots of insects and birds that will take profit of the hamster measures. And that's a way of thinking really, really important, because as we said before, we pay lots for those measures. It's really lots of money, but it's not only for one species, it's for the whole environment of the species, so other species can also benefit from it. And so we have 22 actions distributed in 5 topics. Okay, I would just present you these 5 topics, and I will do a focus on one action. So the first topic is the transversality of knowledge and actions in favor of the lowland ecosystem. So as I said, not only the hamster. The second topic is to improve our understanding about the hamster biology and how it uses its environment, okay, to be more effective in our action of conservation. Third one, to protect the habitat of the hamster, so really crucial. To protect and reinforce the weak populations. So each year we do reinforcement, and also make the hamster known as an umbrella species. What we call umbrella is if you protect the hamster, you protect, as I said, lots of other species. So that's the way we want people to remember of the hamster, not the hamster just for the hamster, but for all type of environment and species. So about improving the hamster habitat, so we have one crucial measure. It's the agri-environmental measure, okay, approved by Europe, so called MAEC. And the aim is really to improve the environment, so to build a mosaic of favorable culture to preserve the hamster. So we still have our 3 areas, okay, the north, middle, and south one. And the colors green and blue, don't look at the yellow one for that moment. The green and blue are all the places where we do this kind of contract, okay. One area, it must be one area to do a contract. It's a collective of farmers. It's not just one farmer who say, okay, I agree to do something for the hamster. It's a group of farmers. So we have 20 collective groups, and they agreed to do measures for the hamster. And as you can see, so with the figures, it's a real improvement of the habitat. Because, so in green, you have the percentage of favorable crops, so alfalfa, winter crops, in the collective areas, okay, where we have contract for the hamster. So in 2019, it was nearly 40%, okay, of favorable crops. And outside those areas, completely outside, it's only 20. So we have really a difference with the contract with the farmers. And just to see what we want, what we ask for the farmers. So in 2023, we will change our rules. It will be a new specification. So before, we already wanted more than 26% of favorable crop, okay, and the payment depends on the percentage. If you do more, your payment is more per hectare. Okay, so it's from 452 to 520 euros per hectare per year. And as we saw already, it's really important to have a cover of the field. So we also ask for 50% of the wheat surface near hamster burrows that isn't harvested, okay, and we pay for it. And about alfalfa, they can't just cut it at once. The max is 50% of the parcel. They also had to sow an interculture, or a favorable interculture for the hamster, so with a mix of grass, legume, and sunflower, and before the 1st on August. And there is also a bonus payment for if you have burrows, and you have to participate at the meeting to organize all the crop rotation. So each year, each collective area of farmers meet and ask where they will put the crops, if they have enough or not, and if they will be able to accept a reinforcement operation. So after 2023, we do this time to add all the knowledge we can gather in the past 5 years, okay? So we add biodiversity, not to have not just lots of alfalfa and lots of winter crops. That's not enough biodiversity. So we said, okay, you can do, you have to do 30% winter crops, but also 5% winter crops or other winter plants, 3% spring plants, and 5% alfalfa. So that's much biodiversity than in the previous one. Still, you have to not harvest some parcel. Alfalfa is still the same about the management to cut it. And about the interculture, we want it to extend because, as we just say, to have a cover field is really better for the hamster to protect him and to feed him. So now you have to do it on almost 100% on the fields, okay, with an interculture hamster friendly, so mix of grass, legume, sunflower. So that's the new one. And in addition with this system, we add, in some cases, other specification. So that's what I told before. When you have a project in the reglementary area, we will ask first to do the project elsewhere, if it's possible, and to reduce the impact, and then to compensate the impacted surface. For small project, they will have to pay for the same measure as previously, okay, with the same specifications. But when it's really big projects, we ask for better measure. We say an intensive one, okay. So the private compensator will have to see with farmers directly, if with the association we have in Alsace of farmers, to put this measure. So it's area of 10 to 15 hectares. Donc it's really little spot. This is the little spot you saw in yellow, okay, on the map. So we try to do it just near the collective area or inside it. and the percentage is more than 50% of hamster-friendly crops. Corn is forbidden in this area, and you have to do at least 3 different crops. Okay, so maximum of diversity. There is a maximum for potato because we don't know if it's really good or not for the hamster. And more important, you must do strip with a favorable hamster-friendly strip between the different culture. So that's quite new right now. So we don't know yet if it's really effective. We hope so. And what we can see at this time, it's to maintain the strip. It's quite difficult because we do always the same culture, and other plants which are not favorable for the farmers are coming in this strip, and maybe we will need more knowledge and techniques to have a better management of this strip. That will come. And it's a 10 years contract at least. Okay. And just to add also about agricultural measure, we also set up. So we have with our partners, the Chamber of Agriculture, the organic part. We're setting a flour. Okay, so with the wheat for the hamster, there is flour, hamster friendly, and we have all the packaging, and it's sell to the consumer saying, okay, you will pay more, but it's for the preservation of the hamster, so that just new. And we have this flour in some supermarkets right now. It's just the first year, the first beginning. And we will try also beer, hamster beer, with favorable crops. That's the next step. Okay, so that's just a point. And just will not go in details, but France is also involved in an Interreg program called XXXIX, so Cooperation Research Project in favor of XXXIX conservation in agricultural landscapes. It will end next year in June. So I hope I will have nice results to present you at this time. Yes, and that we have it's just a support for the National Action Plan. The plan itself doesn't bring money. It's not an obligation. Okay, so we have a plan, but we need to find the money to make it real, to make it to function it. Okay, so this is one financial program we found to do it with our German partners. Okay, thank you. I hope that's clear.
Thank you, Marie-Cécile. That was a very clear overview of the impressive amount of actions that are being implemented in France. I have myself one question, like the 3 areas that are protected. I mean, did I understand correctly that if I want to carry out a project, I want to build some houses in this area, even though site itself, no hamsters are present, but it is part of the designated site. Do I need to carry out compensation measures?
Yeah. In the red part, okay, you saw on the map. It's protected. It's hard protection. So even if you're in the middle of nowhere about hamster burrows, you're really far. You still will prove us that there is no hamster. Okay, so it must have a counting. And even if there is no hamster, it's considered as hamster habitat. So you destroy it. So you will have to apply for derogation and to compensate. Yeah.
Any other questions? Wait.
What's wrong? Really bad at drawing.
see any injuries here, Veerle.
This was a nice presentation. Thank you very much. I have one question about where do you get so many farmers? This group, this numbers of farmers, 20 in a group, and in all this 2,000 hectare. This is much. How you get the farmer in this groups, 20 in a group?
So we began with a few collective areas. So it was step by step. Okay. So at the beginning we have less areas, less farmers, and with the condemnation of the European courts, we had some pressure to say, okay, we have to work together, all right? So we will do it. We will not force you to do measure for the hamster.
This is very
we
nice.
want to do it together, and to we are building also the rules, the agri-environmental measure with the farmers. They are involved because they do the measures. They are doing it. So, and yeah, it's a huge management with the Chamber of Agriculture. So we have to manage all this collective area, an association of farmers. Called AFSAL, Association Faune Sauvage Alsace, with the president, and they took decisions, and we can include them when we talk about the hamster. And they're also involved in the scientific research. So CNRS ask for farmers, okay, what do you think could be good for you and for the hamster? And we will try to test it if it's really okay, or maybe not. But we will not test things if you don't put it in the field. That will not be useful.
A very good work. I saw it once in Hunavir. No? They are very
we have a breeding center in Hunavir. Yeah,
and in the
they're
summer
active.
they make a sunflower fest. So then almost the community is together. No? Huh?
Yeah.
Very nice. Thank you.
Thank you. There is, if it's an urgent question, yes, that's the final question. Yes.
Just a short one, thank you. I've seen now, and it's been mentioned, the threshold of 1,500 individuals on 600 hectares. That is the definition of your target population you want to reach, and after that everything stops? Or is that just a minimum requirement?
This is a minimum. We put it about the knowledge, scientific research. If it's changed, then we will change our numbers, because we want to reach a viable population. So at this time, it's 105,000 hamsters on 600 hectares. So we want to reach it, and that's a minimum. After that, maybe we will have still measures to maintain this population, because we can see how it's difficult to reach a viable population. So to maintain it, maybe it will be also hard. I don't know. But if everything's going on, maybe we will not need a plan anymore. I don't know. But I think it's really far away from here.
Because the background of that that number that is mentioned several times it dates back to a publication of a colleague who very cautiously said that in spring, vital hamster populations should consist of 1,500 individuals, and it's individuals, not burrows.
Not burrows.
In spring, on 600 hectares of hamster-friendly managed fields. So it's not just 600 hectares with 10% of hamster-friendly managed fields.
600 hectares with no hole, with continuity, and you can show that we have.
And the problem is that there are now more recent publications and papers that say that small mammals weighing less than 1 kilogram, you need much higher number in optimal habitats for them to recover. So this is something to bear in mind. But if you set it as a minimum requirement, then you could say, well, we've reached 1,500 and now we have to go further. Thanks.
Thank you.
I think that's a very valid point. It was also mentioned in the ruling of the Court of Justice, these two numbers, but you're right. I think judges are inclined to follow the evolution of science.
And so we are, yeah.
Okay, thank you. And then now we move to the topic of predation. Gerard is going to speak about the habitat use of common buzzards in relation to hamster conservation areas. Well, perhaps not exclusively linked to predation, I assume.
Okay, thank you very much. Yes, this is a presentation without a hamster, but yeah, a predator of the hamster. We just saw in the presentation of Maurice that the buzzard is responsible for predation on male hamsters for 21% and female hamsters for 34%. Now, yeah, one of the reasons to do this research about one of the predators of the hamster was the management we have now in the Netherlands since a few years. And that is, we have in overall in management with 1/3 winter cereals, 1/3 summer cereals, and 1/3 alfalfa, or a mixture from, yeah, a nice exotic mixture. Rick can tell more about these mixtures, but that's, yeah, in our common management. And for the alfalfa, we have now the management that we mow it. We cut it till the 1st of August, 2 or 3 times, 2.5 times, and then only on the half of the fields. So half of the field is mowed, is harvested, and the other half not. And after 3 weeks, then the first part has grown already and has coverage again. Then the other part is harvested. And on that way, we have first, we have better lucerne over more years. And we have the ideas that we have for predators like the buzzard and the fox. And yeah, that are the main predators from the hamster. We have fields which are harvested and where they can hunt. And yeah, you all know when a grassland or a field or also a cereal field is harvested, the first birds you see that are always predators like herons, buzzards, and in the night the foxes. So since 2 years, 2 years, it is possible to put transmitters on buzzards, which collect data about what they are doing. And now I have to look. Yes, these are these transmitters. These transmitters are already longer available, but they didn't work. And with this extra, more leveled panel, solar panel, they work also better for buzzards. And now, yeah, these we use them. They cost about 1,000 or 1,100 euro. It's a backpack transmitter. It weighs 25 grams. And now, yeah, with a bit luck, it can work more than 3 years. And another advantage is you can program them. So if there is a lot of light, you can tell with your laptop home, I want to collect more data. You can, in the software, you can say, for instance, when the buzzard is flying into a hamster reserve or over hamster fields, you can the transmitter knows then, okay, now I have to collect more data, not every 15 minutes, but for instance every minute, so that you can see exactly what they are doing when they are in that area. These transmitters are also used for in bigger form for the white-tailed eagle, and to see when they are in wind parks and they have the risk to for collapse. So that's very nice. And last year I showed already some things about these methods and these transmitters from the first 5, and this year we could catch another 5. So we have now in several hamster areas we have buzzards with transmitters, and analyzing data. I did the last 2 or 3 days, 4 days, a little bit for this presentation. So this is only a quick overview. How to catch a buzzard? The best method is to catch a buzzard near his nest where are small youngs. They are then very aggressive on other birds of prey, and the best bird you can use for catching a buzzard is an eagle owl alive. So if you make a position near the nest here on the left, oh, that's not good. Is back. Oh, yeah, I found it. Yeah. So here on this, but you can see in that tree on the background there was a nest with this small young, and this is a cereal field. It's a hamster field. We put a mist net with the uhu, and then it's waiting. And sometimes you have to wait 3 minutes, 4 minutes, and sometimes you have to wait half an hour. But in most cases, the buzzard will attack the eagle owl and fly in the net. And if you have him in the net, it's you have to be careful to take him out. But that's the second. And then we put him a transmitter on, and by putting a transmitter on, it's very good to hide the eyes so that he cannot bite or wound you. This is nails. And after that, we release him again. On internet you have a website. This is from the company who sells the transmitters. It's Ornitella from Lithuanian. It's a good company, and they produce all kinds of transmitters, and they are very reliable. And even these ones are doing well, except the one here is 0. This is what you can see. Also, you can here program the transmitter with this program, and you can get files about positions, but also about the data. There's another site. You can connect it with this site from Ornitella, that is MoveBank. And on MoveBank, you can find all kinds of projects with telemetry data from transmitters from all kinds of birds over the whole world. And it's a network where everybody can go to and collect or use data. For the first 5 years or 10 years, 5 years, I think, if you bring data to this site, then they are for you, but after that they are free to use. So if you need data from some bird or you want to see something, you can always go to MoveBank and find data about all kinds of different species and about telemetry data from insects to whales. Now the data you get is records, and like I said, here you see records from every 15 minutes, if I'm right. And in this record you have the day, day, time, you have coordinates. There is an accelerometer data are in it. If a bird is dead, then the accelerometer data have another position and they don't move anymore. Then you get a sign, hey, watch your bird, it's maybe dead. You get information about the height. Now, yeah, other information like battery, temperature, about the number of satellites on which the coordinates are fixed, the time that it takes for fixing, and also the ground speed. And that is a column which I also use for flying and sitting. So if a bird is flying, a buzzard is flying, then, nou ja, and you know he's not hunting. If he's sitting or sitting on the ground, it can possibly be in hunting place. Nou ja, and the height about sea level and so on. Nou ja, and of course, you can give this data also the species and the individual. Now, last year I showed you some figures about this pair of buzzards, and yeah, but for us it was then quite new that this buzzard or this buzzard pair, it's a male and a female, were only using a part of the hamster reserve in Sibbe. In the yellow ring, that's yeah the reserve, and you see that the buzzard in later also in the months in autumn also used only the eastern part of the reserve and didn't visit the rest of the reserve. Then we go to the this is the winter, and also in winter time you can see still the buzzard is using his own part, and the area where it's his territory is a little bit bigger, but it's not very clear which points here are from flying or sitting birds. But nevertheless, the main the home range, 90% home range, is still the same. But like you can see, and that was also my question last year, what's happening on the other parts of the reserve? Who is hunting here? There must be another buzzard. And in this spring we had a buzzard breeding here inside the reserve and one just a few meters outside. Just a few meters are 30 or 40 meters. Here the reserve, more bordered like the last picture. And here is the bird we could catch this year, and here another one. But we were a little bit late, so we called them in the beginning of June. And this is the nest from last year. It was also inhabited with the male and the female. And from this nest we only got one bird, probably the female, but we are not sure about it. And these are the data from June, July, August, September from all the birds now. And what you can see is on the right side, dark blue is the male, light blue is the female, red is the bird from the nest Welsden, and yellow is the other points from the area where the kasthuis buzzard is hunting and sitting. And what we now see is, we are still missing one bird in the middle, or there is no bird in the middle. And I couldn't find another nest in this area, so there is a small area between all these three territories from buzzards, which is not used or almost not used. So that's very nice to see. And more nice to see is, that's later. Here on a smaller scale, the data. And here most of the fields are covered with cereals and some with flowers, sunflowers and other things, and also quite a lot of alfalfa. And there is one strip here with that was a 2 years wheat strip, and this strip I come later back on it. It was a very special one because it was, what is it, destroyed, chopped. But for that here, a closer use of the buzzards. And what you can see here in the middle, the more lightened points is a flying animal, a flying buzzard, and the points with dots, black dot in it, is a sitting one. So you can see there are some fields like this one where they were sitting, and here is one where they were more often sitting. And further analyze will show if these were the alfalfa fields, which were, and are these used on the moment that they were harvested? That's what we wanted to know. This is without flying. So here, these are only the points where the hamster, after the buzzards were sitting. And here you can see already this field. Here are a lot of points, and here are a lot of points. And here on this field, almost none. So, and also on an, here you can see that these are the alfalfa fields. So on some fields you see, that they are more and others less. And this is also an interesting field. So I have to find out what's happening there. We release also hamsters in this area. Mostly our release pen is exactly on that place. And more or less, we did it. We hadn't this information about hunting buzzards, but as you can see, the place of the release pen was the most safe place, at least for predation of the buzzards. So if they disappear, it's probably another bird or mammal which takes the hamsters. On one place, and that was very nice to see, that this 2-year wheat strip was chopped, destroyed around the 24th of April. And in the week after it, the buzzard, here the blue buzzard, the male and the female, which were not often in this part, it was on the border of it, they were suddenly on this field almost every day, hours per day on this field between the 25th of April and the 3rd of May. And that was just the week, 1.5 weeks that this field was chopped and was uncovered anymore, but it was not plowed again. So there must be a lot of food on this place. But this stripe was longer than much longer. Here you can see, but they were only in this part, not in this part. This was the area where the buzzard think, okay, here I may not come because that's an inter area which is not visited, and that's also the area where the pen was. Now we have more buzzards. Here on the right side, this is the place which I showed from Sibbe, from the reserve. Here is another place with hamster friendly management, and also a pair of buzzards, male and female, who are transmitted. And from them I have also some data. But here it's also nice to see what this buzzard did. He made one time, it was on the 9th and the 19th and 20th of July, he made one trip here to Belgium, stayed there for one night, and came then back to here. So sometimes they can go over 10, 12 kilometers. But the other one here from Sibbe, that one never went more than 2 or 3 kilometers. Now this is the here area for the people who were on the conference in the Netherlands. This is the farmer where we were for the excursion and for the the ARIS stripper, what is it, the special machine for harvesting. And here we have the nest here, and here alfalfa fields, and also here we have a release pen for hamsters. And this is what the female did this year, from June till September. And what I forgot to tell, all the buzzards which I now show, they all had 1 or 2 youngs on the nest. But here you can see this bird is only just around the nesting place, and especially here on 2 or 3 fields where it's hunting and sitting. And here you have the scale. That's 1 kilometer. So this is, yeah, almost 1 kilometer by 800 meters. And sometimes the bird is here in a park in the city of Maastricht. And then the male, which belonged, it is very flying. And then the male comes, and here you can see the male has, yeah, more or less the same area where it sits, but more in this park. But this male also is sitting on every green top in the here in this, yeah, in the city itself, and here around along the highway. Here's the highway, the A2 from which goes to Belgium. And this is where he's flying. And then the last case, this is also a very nice one. This is something which I saw the last week. We have also a buzzard caught here in Koningsbos. That's our most northern area with hamsters. That's the area where we released a lot of hamsters from, where we released hamsters from Germany, and which is now at this moment very good habitat. A lot of hamsters in the area here with the circle, especially this part. And in this part is also a release pen, and I put a fence around it, electric fence around it this spring. And this this place, you can see this is all where this buzzard was in June till September, till October. And here the yellow points are from the first week of October. This is from the first week of October. And then here, this place where it was never before, and here it was also never before, the last 4 months. Here you see a lot of points, and they are all from the last week. And this field was also shopped in the last week. So this buzzard, yeah, it's exactly what we thought that they did. When a field is mowed or harvested or uncovered, there is a lot of food from mice, or I don't know, I hope not hamsters, but maybe rats to take, and they use it. And if there is enough, then they hunting there. Yeah, this is what I just told. And then I think, yeah, now yeah, short summary. We have now 10 buzzards with transmitter. 9 are working well. 1 I have to catch back because the transmitter doesn't work. Also, the other buzzards, the 5 we had last year had very steady territories. The 5 from this year have at least 4 have also steady territories, but less, yeah, a bit less. Sometimes they make, yeah, they go a bit further. The territories of the males are still larger than from the females, but not, yeah, not very much larger. And yeah, we have at the moment 2 small hamster populations. So if there's a relation between predation on hamsters or not, I hope I can find it in the data when we analyze them better. But I also hope that the coverage of the fields where the hamsters are so good that the buzzard has no chance. But now, yeah, on the other hand, what we see is that the buzzards at least are hunting on the harvested or the fields which are uncovered or less covered, and these fields seem very attractive. Then here, oh, I hope this works. Yes. This is release of the bird with a transmitter, which doesn't work anymore. We have only a few points from this bird. That's very pity. But nevertheless, a nice picture from this bird. Okay, thank you.
Thank you, Gerard. Since we're running a bit behind schedule, I would ask people questions to wait for a while, and we can.
Yeah, but I had maybe one question already online before noon, but it was related to the which raptors are able to capture hamsters. For example, can the long-eared owl predate adults? Do you know, Gerard?
Yeah.
Quick answer.
Young hamsters can be taken by kestrel. All hamsters can be catched by harrier, marsh harrier. So we also have marsh harrier sometimes. We had 1 or 2 hamsters on eagle owl nests. But long-eared owl, I think it's possible, but also, yeah, it's the question if there is a good coverage, if they can take them then.
Okay, thank you. Stephanie, the floor is now yours. Stephanie will talk about captive breeding and the chances and pitfalls related to that.
So hello, everybody. I think you hear me, right? Yes, so I'm Stephanie Monike. I'm a chronobiologist, so I'm working on all temporal aspects of life, especially in the hamster. And I'm involved in the breeding concept of Metela, of North Rhine-Westphalia. And I think I have quite good news. So maybe a little bit in contrast to the talks we had before. So yeah, so I think you know this slide by heart. Meanwhile, I think I show it in each talk. So the hamster's living in a seasonal changing environment and is well adapted to it. So in the times when the conditions are convenient, so in spring and summer, this is a time for reproduction. And then in late summer and early autumn, when the food availability is at its maximum, the hamster anticipates already the harsh conditions of winter and build up a food store, which is used then for hibernation, during hibernation. And yeah, to stay in tune with the environment, the animals have developed a circannual clock, so an endogenous timing mechanism, which ensures that winter can be anticipated and which ensures also in spring that the animals wake up in time from hibernation, which is essential for survival. When you have a look at these environmental pictures, it's of course nonsense if the hamsters breed in winter. So, and this clock is not called accidentally circannual clock. It's called because it's a circa annual clock. It ticks only approximately in the pace of the environmental annual cycle. And for that, it needs to be reset once per year. And this is done by the seasonal changes in photoperiod. And this is what you see here on the picture. And maybe, yeah, you see my mouse also, right? Okay. So these seasonal changes, and normally we double plot everything, which is not working here. Yes, here we go. So, and the hamster, as you know well, is reproductive maybe from, let's say, early April to mid of August. And typically it shows very sharply between mid-May and mid-July. don't know why this is not working. So a very typical activity pattern starting long before sunset and each day at the very same time. And this is a highly risky behavior, but the hamster needs it to be able to detect the very tiny advances of sunset after the summer solstice. The hamster has no watch, so the reference point is the very exact beginning of activity. And then relative to that, it measures the tiny advances of sunset. So it's the circadian clock, the other internal clock the hamster has, which times this activity onset. So, and when then the hamster knows or detects after the summer solstice that sunset advances, which is already then in mid-July, so the hamsters are extremely sensitive. I can't, here we go. Extremely sensitive to these tiny changes. It detects it already in mid-July. Not working very well. Okay. And then gonadal regression is initiated immediately, but visible only 4 weeks later. And the circadian clock is reset exactly by the amount which is necessary, so that each individual animal is set in the good direction and with the amount which is necessary. The circadian clock then, if it's well timed, ensures that in next year the reproduction starts in time. And of course, when it got the signal, it switches off the signal from the circadian clock. So what is important to take from this picture is that at this time of year, the photoperiod has decreased by 1 minute per day only, or the sunset has advanced by 30 seconds per day only. So the hamster is extremely sensitive to this signal, meaning a shortening of photoperiod by 1 minute or advance in sunset by 30 seconds induce gonadal regression. And you should keep that in mind. And yes, has of course long-term effects, which I show you now. In this slide, we have the hamster living in its external environment, which is shown here for 1.5 years, so the photoperiod. And then the hamsters have the internal timing mechanism shown here with a white-gray years for 3 individual animals. And you have here in the middle a red line that should show you when photoperiod change, what happens to the hamster, and during most part of this internal year, nothing happens. But then all of a sudden you have these, the hamster can get a strong delay. That's when the curve goes in that direction, or a strong advance when the curve goes in that direction. So, and this is the so-called sensitive phase. This is a phase when the special activity pattern is expressed. So, and when we go now to this next year, and so there was a resetting the year before in July. I don't know whether this is not working. So, okay, we have then an animal which has a endogenous period length of 365 days, and it gets no resetting because it is in time with environment. The animal next to it here, it's faster with the circadian clock because most of the sensitive phase has passed already, so endogenously. So this animal gets a delay for the clock. And the last animal is lags behind with this cycle, so it's only at the beginning of the sensitive phase and get an advance then in the in this endogenous cycle, so that next year the animals are in time. And what you should get from this is that whenever the animals detected a difference in the environmental cycle and their own cycle, they adjust their clock. And what they don't know is that there might be fake environmental signals. We come to that later. So in our breeding colony, we take advantage of these sensitive phases. And here we have a second one, actually. So this is the one we are talking about right now. And we have a second one here in winter, which is not so well defined. but we can, by using it, advance the breeding, the reproductive period of the animals a little bit. And so we use artificial light, a moderate increase of artificial light, and you really have to figure it out for each breeding colony at which day you start and which photo period you take. So with our in our colony, something around 14 hours of daylight is working out well. And by that, we managed that the reproductive period is advanced. So the onset is advanced, but not the offset, at least not much. So, and that allows us to breed way earlier than in other colonies. And our pups are born from early April on, and they reach puberty. They become reproductive at an age of 6 weeks. So we can release reproductive pups. So and that's what we do. And we can release them. We can also keep them in our colony, whatever. But so we can produce many more animals than in normal colonies. And it has also some advantage on the breeding. So here you see, the 6 years in which we are already breeding, and in 4 years we tried our light regime. We adapted it from year to year, improved it, and I think now we arrived at a good light and date. So we could advance our breeding considerably. So the median was in our first year, it was maybe 15th of June. Now we are at, let's say, 12th of April or something, with a median of breeding of all our couples. And it has some extra advantages. We didn't know that before. So we have a high fecundity at this very early phase of breeding. So we have 80% of the matings are successful. And in the other years, when we bred later, we had less than 50, maybe rather 40%, which were successful. And in this very late year, in the beginning, we had only 18% of successful matings. So, and here's the litter size. Also, the litter size increased in these 2 very early years. So we have, this year we had an incredible mean litter size of 8.4. And so, and this is now outside. So we release actually in 3 sites in Northern Westphalia, and here I show you the results of 2 sites. On the left in Rommerskirchen, on the right it's Pulheim and Ingendorf. So and actually Ingendorf is in the middle between Pulheim and Rommerskirchen. And they monitor in a bit different way, but shows still the same. So we have here in Rommerskirchen, we have 3 sites where we release hamsters. One's called 20 Morgen, the other one is called, the red one is Hahnen, and the gray one is called Schützengrund. And here are then the monitoring. When there is a green star, in that year we have released hamsters at that site. And then they have also monitored 150 hectares beyond all of these releasing areas. And you see also these yellow columns are increasing. We have now a total, after just a few years of releasing, a total of 701 hamsters here, and of 987 hamsters in Pulheim and Ingendorf. So here it's just the areas, they don't have these areas beyond the releasing site, they have just these 2 areas monitored. So we have some fields with densities of 50 hectares, 50 hamsters per hectare, but a mean of 4.3 burrows per hectare in Rommerskirchen, and I can't read it right now, 3-point-something in Pulheim and Ingendorf. So a total of 1,731 hamsters. And for the ones which are new in this group, in 2017, the hamster was still more or less extinct in in North Rhine-Westphalia. At least we couldn't find any more. So, and we have detected another advantage of this timing schedule. So here's our release time. So we released for the first time in spring. We released in 2019. Before we released some animals in autumn in 2018. So for the spring release, we were quite late in 2019, and then advanced our releasing time more and more. And this year, the median of our releasing time of adults was still in April. So, and we finished with releasing adult animals in this year before the 15th of May. So the 15th of May is this critical date when the sensitive phase starts, when the hamsters shouldn't be disturbed anymore, not to interfere with the resetting of the clock. And this year was the first year in which we managed to have all animals out by this date. And so, and we had another nice side effect. This is what you see here on the right side. In 2020, we found the first open burrows here in calendar week 14, which is here in early April. And in 2021, it was already considerably advanced to week 10 in Rommerskirchen and week 8 in Pulheim. And in 2022, the first open burrows were in week 7 in Rommerskirchen. So we assume that also then reproduction starts earlier in these areas. So we have two hypotheses. One is that we have actually quite high population densities, and from old literature, where they describe also hamster pests, we know that in the pest years, reproduction starts early in the populations. And maybe just because of the idea that, okay, you want to be the first with your offspring, that your offspring has still nutrition on the field. So before all of the others come, so your offspring has already grown up. The other hypothesis is that early born animals reproduce early in the next year. And why early reproduction is so important. Oh no, so here's again monitoring from Rommerskirchen from Michael Stevens, who in his group, they monitored the field in spring for the opening of burrows. So 2 fields actually, so Hahnen and 20 Morgen. And they noted how many burrows were already open. And here in 20 Morgen, 55% of the burrows were already open by mid-March. And here was just a little bit later. It must have been somewhere here, maybe a week or something later. So here they had already 70% open. So, and that is quite good, because these animals might then become reproductive early. Photoperiod is then stimulating outside, and they should be reproductive, within the next 4 weeks. So, and why is that so important to be so early? So you might have hamsters born during the whole breeding period. You might have early born animals and late born animals. And please pay attention here. I call late born animals which are born from June on. These are late born animals because there's a big difference between these two. So the early borns, they reach puberty and grow rapidly within an age of 6 weeks. So then they can participate in reproduction and reproduce. So they potentiate your population. So these are, it's already what Anja Kaiser said, these are the most important animals of a population. And most likely these animals don't exist anymore. So, and the others which are born later, so the late borns, they stay small and won't reproduce until next year. So they need to survive several months until they reach puberty and become reproductive. Most of these animals won't ever reproduce. So, and that is why it is so important to, if you want to release hamsters, to release them so early that they reproduce so early in the field that they can produce these early born litters. So, and this is now when it comes to pitfalls. So this is the reproductive scheme we are using. And I know from my time in Strasbourg that they did it in that way. And I got 2 years ago still a call from a student there, and they still used this breeding scheme. So they put the hamsters on a maximum photoperiod on 1st of January. Good idea, because then you advance the onset of reproduction. But in that case, you advance also the offset, because it's way too early. The productive time has finished. Then when you when then the photoperiod is shortened again in the breeding colony, and especially when you want to release hamsters. So normally hamsters are released maybe in May, or even if you want to release earlier, that means a strong decrease of photoperiod by half an hour or something. So at the moment of release, you stop their reproduction. So these animals are not reproductive anymore. You could release as well dead hamsters. They don't add anything to your population anymore. So another, yes, so there won't be pups from these animals. So, and there's another. So we have quite a few new actors in Germany. So a lot of zoos want to support us with breeding stations, which is actually quite nice. But there's another risk for losing of fecundity, and these are there are a lot of animals moved, and I read most of it in newspapers. So don't or take it for granted. We just take it as example how it might have been done. Normally in newspapers, it's not everything correct. So these are possible scenarios which are there, and some of them are certainly done. So we have a quite far distant transport. And what you should keep in mind by that, because sometimes it is necessary, that you have quite huge longitudinal changes in photoperiod. So I give you here the photoperiod of profile of Hamburg in this brownish color, of Hildesheim, of Fulda in green, and Stuttgart in yellow. And on the longest day, you have between Hamburg here and Stuttgart here at the bottom, you have nearly an hour difference in photoperiod, as well as in the shortest day. So if you want to transport hamsters safely, also keeping their reproduction, you should do that here around the equinoxes, or adapt it by an artificial timing. So, and you could also have latitudinal changes in sunrise and sunset times, which are also quite large. So here is Osnabrück in the west, then Hanover and Berlin in the east. Between Osnabrück and Berlin, you have a 20-minute difference in sunset times. So I told you 30 seconds are enough. Here we have 20 minutes, as well as for the changes in photoperiod with the longitudinal changes. 1 minute change is enough to stop reproduction, and here we had up to 1 hour if you go through this map. And if we just go into these examples, here was a transfer of animals from Heidelberg to Gotha, which is close to Erfurt. So here we have the direction. And here's a conflicting signal. Photoperiod is increasing, but sunset time is advancing. Maybe not so much, and maybe this effect was larger. So maybe that was a lucky case, nothing happened. And these animals should stay there, at least what newspapers say. There's another transport from the area around Erfurt to Leipzig. The photoperiod stays nearly the same. Sunset time advances more, so here's a higher risk already that you lose fecundity. Next example was from Frankfurt to Osnabrück. No problem. In Osnabrück, the photoperiod is way larger than in Frankfurt, and also sunset time way later. However, these animals should come back. They should be released in the Frankfurt area. And this is not possible unless you go to start with a timer and mimic the photoperiod of Frankfurt. But yeah, this is also a thing of timing. Normally, somebody said, okay, we need to start now. We need to do it now. Then the animals are there. Then somebody said, okay, Stephanie thought it's not a good idea. We need a timer. Then a week later, you introduce your timer. Don't do that. You mess everything up. So if something like that happens, just ask me. And but otherwise, you will lose fecundity. Then there's another transport from Göttingen to Berlin. We have an increase in photoperiod, but a strong advance in sunset time. So you certainly will lose a lot of fecundity if your animals won't even stop reproduction. So please keep that in mind, that even things like that have an influence of the timing. And once the clock of a hamster is messed up, it's kind of seasonal jet lag then. As you know from your daily jet lag, when you do a flight to America, several cycles to be in time again with a new schedule. So if you count it for seasonal cycles, you would need several years to arrive again at the new cycle. The lifespan of the hamster doesn't allow that. So once the hamster is messed up, it is messed up. So just conclusion, early breeding increases the fecundity and increases litter size. Early release gives a higher reproductive success outside. The offspring reach puberty in the year of birth. Potentially, it leads to early reproduction in next year, and it might be a key factor for growing populations. Whatever a light regime is chosen, it needs to be chosen carefully. And animal transports, please consider that photoperiod and sunset times are changing on long distance. Thank you very much.
Thank you, Stephanie. That was very inspirational. We saw a lot of positive. Germany, numbers going up instead of going down. That's a change. We have one question from the online audience. What is the chance of survival of an early release if the landscape is not yet covered by vegetation? How do you take that into account?
Yes, that's of course a conflict. And if you want to do such an early release, you have to do whatever is possible to increase the cover. So may it be fertilizer, may it be watering. So in 1 year, actually, we had the fire workers coming to water the fields because we had a drought in spring and vegetation was not growing. And we had the fire workers coming and pumping water on the fields.
Okay. Are there any other questions? No urgent questions? So then we thank. And we continue with our next speaker, Julie, on the improvement of the success of restocking programs.
Hello, everyone. So my name is Julie Fletz, and I'm doing my PhD right now. And I'm working on trying to find method to improve the success of a restocking program for the European hamster. So I wanted to briefly talk about what are the restocking program. As you may know, it's the fact of taking an individual from an environment. It can be a captive environment, or it can be a wild environment, and releasing it in a new environment. It's a method that is currently used in conservation biology in order to preserve endangered population. The problem with this program is that often the success is a no, because the animals that are released are not followed after the release, so we don't really know what happened to them. And some study analyzed the success of these programs, and they saw that the success was low, and this low success was often due to a heavy short-term mortality quickly after the release. So several reasons can explain this short-term mortality, as the unfamiliarity with local condition, for instance, or the limited foraging capacity of the newly released animal in an environment that they don't know. There is also the deficiency of the immune system, and some study show that sometimes they observe abnormal behavior with predators. This last point can be a real problem for solitary prey species as the common hamster. Just to briefly speak about the situation of the common hamster in France, as you may know as well, you can only find the species in the Alsatian region, which is at the extreme east part of the country. And some studies show that the population in this region decreased of 94% these last 50 years. So to try to preserve the species in the region, it's been 20 years when restocking programs are applied. So for the common hamster, predation is the major cause of mortality, and is the case for captive bred hamster, but also for wild hamsters. To try to limit the predation on the newly released animal, there is some strategy that had been developed. For instance, we install electrical fences around the fields where the hamster are released to limit the terrestrial predation. And also the hamster are always released in a field cover with permanent wheat cover. Although, despite this measure, we still observe up to 50% mortality, sometimes 3 weeks after the release. So my work was to trying to find some way to increase the survival of captive bred hamster that are released into the wild. And my goal was not to work directly on the environment where the hamster were released, but more on the, let's say, quality of the hamster that re-release. To do so, I study what is called the impact of a soft release. So the soft release is the idea of releasing the individual in a semi-natural environment before releasing them definitely into the wild. So to study this soft release, I worked on adult and juvenile hamster. I first did some tests in control condition, and it's the first study I will show you. And then I also follow the hamster after the release to see what happened to them. So the first test, maybe you remember it, I showed it to you 2 years ago. It's what I call the predation test. So the goal was to see how captive bred hamster react when they were confronted to a fake predator. So the hamster were released in this PVC arena. We had a fake fox that we could push toward the hamster to simulate an attack. And the hamster could hide inside the tube that is in the middle of the arena. What I did is that I took hamster from captivity. And so it was adult and juvenile hamster. I did this study as well only on female hamster. All the individuals went under a first predation test. Then part of the animals went back to their breeding cages for 2 weeks. So it was my control group. The other group, what I call the enclosure group, was released for 2 weeks in a semi-natural environment, which was a big outside enclosure. After this 2 weeks treatment, I got all the animals back and I tested them again in a second predation test. So the goal of this study was to compare the behavior of a hamster before and after the treatment, and also between the groups. So what I observed, it was that after the 2 weeks in the outside enclosure, so the enclosure group, when they were confronted again to the fox, they were hiding faster and for longer period of time than the hamster from the control group. What I also observed, it was that with or without the 2 weeks treatment in the outside enclosure, we did not observe any differences in the behavior of the juvenile. And we did not observe differences for this group because same during the first predation test, the juvenile were hiding very fast inside the tube and they were staying hidden during all the tests actually. So I got these results and then I wondered, okay, some hamster, they live for 2 weeks in the outside enclosure and they hide faster when they see a fake fox. But it doesn't mean they will have higher survival rates once they will be released into the wild. So what I wanted to know after it was to see if these results were actually a good proxy for the survival of the hamster after the release. And it's the second study I did. So the study I will show you now, I did it last year and I did it this year. I made several groups of hamster as well. So my first group was my control group. There were 16 one-year-old female in this group in 2021 and also in 2022. Then I had the enclosure group. Once again, 16 individual every year had been tested. They were also 1-year-old female. And the differences between the enclosure group and the control group is that the female of the enclosure group were released in big outside cages for 2 weeks before the definitive release into the wild. So here there is a drawing of the cages and you can see a picture as well. What you can see on the drawing is that the hamster had a little space where they could dig a burrow. They also had access to fresh food and they were outside, so they were in a natural climatic condition. We installed camera traps close to these outside cages, and we saw, for instance, when some predator passed by, like a fox from time to time, ferrets, sometimes we saw other animals as rabbits, etc. Another group that I tested was my sub-adult group. So there were 3-month-old female hamster. I had 16 individuals in 2021. And in 2022, I had a juvenile group. So these ones were 6 weeks old when they were released. I equipped all the individuals of every group with RFID for just identification, and they also had a telemetry logger. So with this logger, we could know where each hamster was after the release. We could find their burrow, and also this logger, with this logger, we could know if the hamster was dead or alive. All the animals had been released on the 2 different sites. So 48 animals were followed in 2021 and 42 in 2022. So they were all female, but they were released at the same time with males. It's just that I didn't follow the survival of the males. I was only focusing on the females. When I released this female, I follow the commonly used protocol in France. So the hamster were released in fields that were surrounded by electrical fences. The fields had permanent tweed cover, and the hamster were released as well in artificial burrows. So after the release, I collected survival data twice a week. So from mid-June until hibernation, so until October. And also I collected the data of reproduction once a week. So to do so, I used camera traps, and we did quite some nocturnal capture that I will detail a bit more later. So I will show you some preliminary results because I don't have all the results yet, as the fieldwork only finished last week for the study of 2022. So I show you what I have for now. So far, we didn't see any differences between the groups if I combine the year 2021 and 2022. Also, we can have a look of the survival rates. So for 2021, I got this graph. And what you can see is that we observed a good overall survival rate 80 days after the release. So it was a bit surprising, but it was a good result. What we also observed is that 45 days after the release, which was the time more or less when the first litter emerged from the burrow, we saw a tendency between a difference between the control and the enclosure group. And also what we observed was that the sub-adult had a survival rate that was similar to the other group. We did not really expect this result because we know that usually young animals have quite higher mortality rate than adults, but last year we got this result. So now if we have a look at what happened in 2022, we can see it was quite different from 2021. So first, we observed that 80 days after the release, there were a lower survival rates compared to 2021, with a less than 30% survival for the control and the enclosure group. As well, we did not observe differences between the group, and we also observe very high mortality for the 3 groups after the first litter estimate birth date, so 21 days after the release. So now if we have a look at the reproduction data, so also preliminary results. So to try to estimate how many pups each female of each group had, we did several things. So the first thing was to install camera traps in front of the burrow of each female we follow. When we started to see the first pups coming out of the burrow, we started to try to capture the pups next to the burrow of each female. And when we capture the pups, we collected hairs to do some genetical analysis. So far, the results I will show you are only the one for 2021, and they are only based on the camera traps analysis and on the catches. So for the 3 groups, so at the beginning there were 48 individuals, we catch 220 pups, which was pretty good. And we know that all the females that were still alive at the end of the season, they had 2 litters. As I say, the genetical analyses are not finished yet. They started, but we don't have all the results. So we are still waiting for this result to confirm the pup's mother assignment. Although the first result we got confirmed that the sub-adult groups, so hamsters that are 3 months old, were able to have pups. So to discuss a little bit the result I show you, what I can say is that I observed pretty big differences between the 2 years. What we know is that the climate was pretty different in 2021 and in 2022, because in 2021 we had low temperature and high rainfall, and in 2022 we had the complete opposite with high temperature and drought. So one interpretation we can make, well, one observation we made first is that the high mortality rate in 2022 started when the first litter was born. And it was exactly at the same time, basically, when the drought period started in the Alsatian region. So the hypothesis can be that they were, because the female had the pups at the time, they had a very high energetic demands in a very difficult climatic period, and maybe it had been fatal for them. Also, maybe the predation pressure was a bit higher at the time, because in the region it was a really hard time for all the animals. To conclude, what I can say so far is that the 2 weeks of soft release, they may help the hamster to adapt more quickly to a new environment, although it doesn't seem to be enough to improve their survival after the release. Also, what we saw was that the 3-month-old, they were able to survive as good as the adults, and they were able to reproduce. So maybe it could be interesting to improve the restocking program to release young individuals. Also, to have 3-month-old hamster mid-June, we had to artificially modify the photoperiod in captivity. Maybe in every breeding center is not going to be possible. So what will be very interesting now is to see if the 6-week-old hamster that we released were also able to have pups. And we saw that the survival rates was actually the same as well than the other groups. So maybe actually younger hamster release could be as well a good option for the improvement of the restocking programs. Thank you all for your attention. And if you have any question.
Thank you very much, Julie. Do you have any questions from?
Yeah. Just a quick one, Julie. Thank you for your presentation. When did you release? When was the time of release for your experiment?
So in 2021, we released them mid-June, and we released them a week later in 2022. So I know it's a bit later than in some other country.
And that means the 3-month-olds did reproduce already.
Yeah, they reproduce when we release them. Apparently, they reproduce at the same time than the adults.
Right. Okay, thanks.
Wait. Be able to follow.
One question for me. How big and how heavy the transmitter you implanted in the animals?
Yeah, so we implant the transmitter in the intra-abdominal cavity. It's like 3 centimeters long, something like that.
Oh.
No, smaller. Maybe 1.5.
Okay.
And the weight, I forgot. I have to check that. But yeah, they seem to 5. The answer there, 5 grams.
Okay. And then one final
Thank you.
question from the room.
We released juveniles in the Netherlands, and we released juvenile hamsters in the Netherlands, and they did reproduce. So we had 26 juveniles only, and the population increased there. So that was a good proof, and that will probably work very well if you do so.
Yeah.
Okay, thank you. And then we have one final question from the online audience. Mikhail, did you try to release hamsters that were younger than 3 months?
Yeah, it's what we did this year. So we released a 6-week-old hamster.
Okay. Thank you. And now we move to the final speaker before the break. And that's on burrow infrastructure improvement and reintroduction. Malu from Germany.
My laptop.
Sag mal, hier ist Inflation.
Dann muss ich den eigentlich lang machen.
Ja, das sowieso.
Ist ja ständig am Wandern.
Ja. Das setzen wir auch mal aus.
Stefan, ich habe gerade noch Hilfe und Jörg auch ein Mikrofon fotografiert, weil das finde ich echt geil. Echt total klasse. Ja, du kannst dann.
Das ist Teamwork.
Het plaat is echt super mooi. Ja. Niet deze halsziekte.
Misschien ja, de presentaties na de pauze vragen om vragen aan het einde te stellen. Anders wordt het veel.
Ja, voor mij is het voor.
Ja, perfect. Ja. Ja, een foto, dan.
Ja, op wel dan mensen ervoor. En...
Ja, ja. Ja, wil Stefanie had dat ook voorgesteld, hoe laat het is.
Ja, wir haben, nee, eins hat uns noch gefehlt.
Seated, please. So without any further ado, we now give the floor to Malu from Germany, who will discuss burrow infrastructures and the possibilities to improve successful reintroduction. The floor is yours.
Thank you, Vibsh. Just going to wait for the last 3 people to come in. Okay. Hi, my name is Malu Antrobus-Toraye. I work for the Institute für Faunistik in Germany, where I do the breeding, but I brought you a talk about GIS, so nothing to do with breeding. So we also do the yearly censuses, where we send teams of people across the field to look for burrows to have an estimate of how many animals are in our release sites. And we noticed that we keep finding recurring burrows in the same places. So then we decided to do a GIS analysis of that, just to see if we can get any further information from there, or yes. So this is the area of Straßenheim, which is currently our most successful release site. And all these little dots are waypoints of burrows that we've found. And the different colors are different censuses. So yeah, so we found, we started in 2018 and once, and then 2019 we had 1 census, 2020 we had 2 censuses, and 2021 we had 3 censuses. This is a little bit closer if we zoom in, and then I added a 3-meter buffer around each burrow to make up for the inaccuracy of the GPS. Yes, GPS can be a little bit more inaccurate than 3 meters, but if I did it too big, then I would have a risk of actually combining 2 burrows that are actually 2 burrows and not just an unprecise GPS. So then if you look at these buffer zones, I picked out those where 2 burrows or more were within the buffer of 1 burrow. And then those I consider to be the same one. And from there, I created a new layer, marking all the burrows that were repeats. And then I also put in the information on each burrow, so how often they were found, how many years, and in which years they were found. And I ended up with an extra layer like this. And that was my end result. So in total, we had 116 burrows that were found more than once in these 4 years. 24 had been used in 3 consecutive years, so from 2019 to 2021. And then 92 were found in at least 2 years. 76 of them were found in 2 years after each other. And then 16 with a lapse where we don't know if this lapse is because the burrow was not used or just because we have humans looking for the burrows and maybe they missed one. And actually these are possibly used over the span of 3 years instead of just 2. Then I would like to add that this is obviously a minimal result because the data we used was data we already had. So this isn't systematic research, but we used waypoints that we've already had. And that means we didn't cover, excuse me, we didn't cover the exact same area every time we did a census. And if you look at the results, the main area where we find repeat burrows is also the area where we have repeat censuses. And we could imagine that, for instance, up here in the north, that it's very possible it would look the same if we actually had data for that area. So these 116 are a minimum result. And our argument is that these burrows and existing burrows could possibly be a very important factor in successfully rewilding the hamsters and maintaining stable populations. Because if hamsters are released into a site where there are already burrows, they can save energy. They don't have to dig new burrows. They're not exposed as much while they are digging new burrows. If you have wild reproduction, the young who then wean from their mother's den, if they can then find a new burrow easily without having to dig one first, will logically improve their chances of survival. So then we have improved recruitment of the next generation, recruitment. And then obviously predation pressure should be lower if we have existing burrows and openings in the ground where hamsters can disappear into. So we conclude that burrows also appear to be passed down through generations. We have concrete evidence of that through the catch, mark, and release projects that we also do, that Marco does. He's very happy to tell you all about it, where we find hamsters that were released in a different area and we find them again and they're living in a burrow that we know exists longer than the hamster has been alive. So we know that they reused the burrows from other hamsters. And we argue that if we want to release hamsters in new territories where these infrastructures don't exist, then we should take into consideration that it's possible that this is a disadvantage to the hamster's survival post-release. And then maybe we can look at how we can make up for that if we want to find release sites where these infrastructures are not there. Obviously, I would like to do this better with more data. So if we had consecutive years of covering the entire area, we would also have more data points, like I mentioned earlier. And what I would really like to do is, because we focused now only on a release site where our hamsters are actually doing quite well, I would also like to compare that site to other sites we have where we're struggling to establish a population that keeps collapsing despite our releases. And if we could do a direct comparison between these 2 release sites, we could maybe get better insight into how important these burrow infrastructures can actually be for successful reintroduction. was a very quick talk, but I'm sure everyone's happy about it because we're behind on time.
Thank you. It was quick but very insightful. And from my lawyer's perspective, there was this ruling on hamster burrows 2 years ago from the court where it stated that also existing burrows which are currently not actively used, but there is a chance that they might be reused, are still protected. It's also the Commission's view, guidance document on strict species protection. But from what I learned from your presentation, it does appear to be sensible to also attach protection to burrows that are currently not used because they might be of future use light of reintroduction programs, right?
Yes, exactly. So we have anecdotal data on that. So we
It's
know
relevant. So we keep additional questions. There will still be room at the end. So we now move forward with the next speaker. So thank you once more. And now we move to France, to the Alsace, where Oksana will tell us more on the hamster distribution model from a case study in the Alsace.
So as you can see on the screen, our online participants are also having their own discussion. I've put the chat for now so you can quickly read it.
Hello, everyone. So I'm Oksana Grant. I'm working at the French Research Center of Functional and Evolutionary Ecology. So since December, I started to work with colleagues from the French Biodiversity Agency on a distribution model for the common hamster in Alsace in France. So I will do a presentation in 3 parts. First, about the context in Alsace. Second, about the monitoring of the species. And third, about the distribution modeling. So let's go to the context first. So this is a map that Julie presented already. But you see that Alsace is at the western limit of the species range in Europe. And as the rest of Europe, the Alsace has known a great reduction in the distribution of the species for the last decades. And so to stop this reduction, France has launched its first national plan between 2004-06 with various considerations such as monitoring, scientific research, releases of captive-born individuals, agri-environmental measures, or awareness. And you can see that they were all done in the gray areas on the map. But the problem is that all of that was done without strict protection of the habitat, meaning that we could still build roads or buildings, for example, on hamster grounds. So this is why the European Commission launched a lawsuit against us in 2007. And so to avoid the sentence, France launched immediately a second national plan in 2007. And this time the habitat was fully protected, but only on a very small area. So you see it's the black areas on the map. So it's only a fraction of the distribution at that time in brown on the map. And it was only, it represented only 2% of the 1972 distribution. So this is why the European Court of Justice said that it was not enough. And they sentenced France in 2011. And so to avoid to pay a very high fine, France launched its third national plan in 2012. And this time, the whole non-distribution was under strict protection. The derogation for urbanization were better defined. And for example, to get a derogation, the companies needed to compensate, for example, through releases. And it seemed to work because the decrease of the population seemed to stop. So this is why the European Court of Justice suspended the procedure against France in 2017. And we are currently under a new national plan. So the dates are wrong. It's 2019 up to 2028. And it basically follows the previous national plan. So let's move on to the second part about monitoring. So the objective of this monitoring is to get an annual abundance index of the species in Alsace. So I will present the protocol through 4 questions. First, what are we looking for? Well, not for the animals directly, but for the burrows, because it's easier to see, of course. And when are we looking for them? Well, in spring. So why that? The main idea is to get 1 burrow per adult. So by surveying immediately after the end of the hibernation, we avoid to count first the burrows of the youngs because they are not born yet. And second, we avoid also to count abandoned burrows by adults because hamsters are known to dig several burrows during the year. And also because it's easier to see the burrows because the vegetation is less thick. And the next question is, where are we looking for burrows? Well, we are looking only in 3 types of crops. So winter cereals, alfalfa, and maislin. So because according to a study in 2000 in Alsace, these were the favorable crops. So we kept that definition. And now, last question, how are we looking for them? Well, by doing linear transect. So you've got several people aligned, separated between 3 and 10 meters according to vegetation thickness. And we do only 1 visit per plot. So here are the results of the burrow survey from since 2010. So you can see that the number of burrows varies between 200 and 700. The problem is there is no measure of uncertainty with this protocol. And because of crop rotation and because of the fact that we are only looking in 3 types of crops, the survey plots change every year. And also what was favorable crops in 2000 may have changed since. So this is why it's quite difficult to interpret the annual variations across the years. For example, is the increase in the number of burrows since 2015 really a result of the increase of the population, or is it maybe just the results of the flaws of the protocol? Moreover, the surveys are only done in protected areas, so in black on the map, and also the protection depends on the burrow location. So you have to imagine that if you are only looking within the protected areas and if the protection depends on the burrow location, then it's quite difficult for the hamster to return outside these protected areas. So because of that, we may change the protocol in the future. And for example, we could do more than 1 visit per plot for the transect part. So we could evaluate the uncertainty. And also for the favorable crops, we could first expand the surveyed area going outside the protected areas and also update the suitable habitat definition, the favorable crops. And so we could get help for that from species distribution modeling. So you see where I'm going to the third part. So the objective of this work is to better target the surveyed areas of the future monitoring protocol by estimating the favorable areas for the hamster at the landscape scale. And we are modeling the distribution of the 1,210 cells of 25 hectares each in the Alsace plain. So in the cell that you see on the map, right? And for that, we are using the data set from the surveys, from the burrow surveys since 2012 up to 2021, except in 2020 because there was no survey because of COVID. But the use of this data set involved several methodological challenges for the modeling. So first, there was a risk for imperfect detection. So what it is, well, imagine you've got a cell. If the species is not present on the cell, there is no risk to detect an hamster burrow. But if the species is present, then you can detect a burrow, but you can also miss it. And you could only conclude that the cell is not favorable to the species, whereas it is. Moreover, you've got also a strong temporal influence because the state at year -1 could have a strong impact on the spring survey at year 0. So you have to take that into account too. So for that, we used a very recent package in R called SP occupancy, and it allowed to take into account imperfect detection. So basically, it divides the model into 2 submodels. So the ecological model, which determines the presence of the species, and the observation model, which determines the detection of the species. So the whole set is most commonly called occupancy models. And also it allows to do multi-season model so that to link all the survey results, all the survey data sets, so you can include the effect of time. So here I try to schematically represent the model we used. So we have 2 variables to explain. The first one is the burrow present within a cell for the ecological model, submodel, and also the burrow detection for the observation submodel. And we try to explain the variation in these variables through explanatory variables. So for example, we had spatial variables, only spatial, such as soil permeability, distance to forest, but also only temporal variables, such as rainfall or temperatures, and spatial temporal variables, such as crop type, releases, agri-environmental measures. And for the observation submodel, we only tested the effect of the surveyed week, the surveyed area, and the year. So I will not show you all the variables, otherwise it could be a bit boring, but I have selected some of them. So the first one is the burrow detection. So it's the variable to explain of the observation submodel. So you can see here is a map of 2012 as an example. In light green, you have the cells where the survey failed to detect a burrow, and in dark green, the cells where it did not. Also, a spatial explanatory variable of this ecological submodel, the network development and persistence index. It indicates the permeability of your soil. So the lower the values, the more water gets in the soil. And you also have the another explanatory variable of the ecological submodel, the total core area of the standing crops, for example, in spring, but we also did that for winter. So basically, it's the number of hectares covered by standing unharvested crops. So it indicates the level at which hamsters can find food or shelter in a cell. And we did the calculation with the landscape matrix package. And last but not least, the releases, because you have to know that France releases every year captive-born hamsters. So they did that just after the survey, the burrow survey. So they did that in June. And here is a map of 2021 as an example. So here are my first results. So they are only preliminary because I'm still working on it, but we can have a closer look to some of them. The releases, you can see that you have a strong positive effect on the presence of hamsters for the releases of year -1 or -2 before the monitoring. So this is really not surprising. And we also have for the total core area of standing crops, for those in spring, we have a slight positive effect. on the presence. For the winter version, the distribution overlaps 0, so there is not a significant effect. For the version of here -2, and the version of here -1 was not even selected. So this could indicate maybe that the hamsters have already relocated their burrows before the monitoring and right after the end of their hibernation, according to where they can find food and shelter around them. Also, for the forest, you see a positive effect. So the farther the cell from a forest, the likelier the presence, so which is consistent with what I've read in the literature. And finally, for the observation model, the surveyed area, you see a positive effect, meaning that, which is not very surprising too, the higher the surveyed area in a cell, the likelier the detection of a burrow. So these previous results could be quite promising, but when I used them to predict the distribution of the species in the Alsace plain, it's less promising. It's more disappointing because the model predicts that the hamster could